we need to now we needs to represent this chiral carbon as a center, okay? And all
Mm-hmm.
the four groups. The first group is this one, CH3, CH2. Let's suppose I'm putting this CH3, CH2 here. Then H and COOH, H and COOH, and the last group is OH. Okay, now you give numberings to them.
Oh,
Yes.
I did it like completely differently than what you did. I had like four carbons
So there is
on
no
the
issue.
on
See,
the line.
there is no issue. You can do or write anywhere, but the answer, in the end, there must be S configuration. Okay. Maybe it
Mm-hmm.
is wrong because I'm just trying to solve. Okay, it can be wrong.
Mm-hmm.
Let's suppose start giving number first, second, third, and fourth. Okay, first, second, third, fourth. This is clockwise or anti-clockwise?
Anti. No,
Anti.
yeah, yeah.
Yeah, anti-clockwise. Anti-clockwise means S. But this is the fourth group is in left and right, so I needs to change. So this is R. So this structure is correct? No. So what I'm going to do, I need to make a structure that is having S configuration. So
Mm-hmm.
how can I draw that? Can I switch the position of COH and H like that? Let's suppose that this is first, then this is fourth, third, and let's suppose this is second. Can I draw that? First, second, third,
Yeah.
and fourth. This is clockwise. Clockwise means R, but as fourth group is in left and right, then it will converting into S. Okay, so the structure can be like this: CH3, CH2, OH, COOH, and H. Okay.
Wait, 1 second. Can you check? I sent Dhananjay J sir a picture of my work. I
Okay.
don't think you understood like how I did it. It was like really like I don't know what I was like thinking. It was like really different. I just like wanted you to look at it if that's okay.
Okay. Okay. So you are making a compound, and in that case, you assume all the centers as chiral center.
Yeah. Yeah.
How? Like we discussed that now that chiral carbon needed all four groups, all four different groups. So see, there is three same hydrogen. There is same two hydrogen. Are you getting my point? We only
Uh, okay.
we only can form a chiral center when all the four groups are different.
Mm-hmm.
Okay. I think you need to practice more questions.
Yeah, actually, it's easier
Mhm.
for me to draw a fissure from like a wedge dash, but I don't think it's easy for me to do them from molecular to formula to fissure. That one's a little more difficult.
Okay, so I'll give you one molecular formula. Okay, wait a second. Do you have any doubt in this question? Now, do you understand like what is your mistake? Hmm? Do you understand?
CH3, CH2 is one thing,
Yes.
but how would I know it's one thing?
Because in this case, you needs to hmm, you needs to draw a Fisher form. Okay, and in the question there is written that there is only one chiral center. How we identify that there is only one chiral center? See, in the question, there is S, which is configuration, that is returned only for one time. Okay, so S2 hydroxybutanoic acid. So S and 2. So in this case, at the second position, there is a S configuration that is written in the question only. See, at the second position, there is S configuration. And also there is a hydroxy group. Are you able to understand?
Yeah.
Okay. Okay, I'm giving you one more example. Okay, that example will. Okay. So see, there is a 21 question, 21 number question.
Okay.
Do you have 21 number question?
Yes.
Okay. So let's draw that structure. How you'll start that 21 number question?
It's a cyclopentane, sorry, butane, right? So
Hmm.
it's like just like a box structure, right?
Mm-hmm.
So you're gonna have Br on one side and Cl on the other side, right? One and two.
At
So,
one and two position, yes. And
um,
then
oh, one is R and then two is also R.
absolutely.
So,
So how
um,
you'll start that?
um, how would I mean? Okay, one R means okay. So if bromine is the first carbon, then I mean, what other groups would be? Because you need four different groups for a chiral carbon, right?
Sorry. In this
Chiral
question,
carbon.
firstly you needs to. Okay, so let's start with the structure of that compound. Okay, so there is a cyclobutane. Firstly, we will make cyclobutane. So this is cyclobutane. Okay, okay. And in the cyclobutane, there is, let's suppose I'm giving numbers, first and second. At first, there is a bromo attached, okay, bromine,
Mhm.
and at second, sorry, chlorine is attached. Okay, done. Any issue up to
Oh,
now?
yeah, I did it wrong
Mhm.
again. I put both. So on the top, I put bromine on the top, on the left, and then chlorine on the
Yes,
right.
yes, that is also okay. There is no
Oh,
issue.
okay.
Okay, so let's suppose how you are draw. So at this position bromine, and at this position chlorine. Are you drawing like this?
Yeah.
Okay. Now, the bromine. Okay. So, if is there any vacancy left? So let's suppose if I'm putting bromine like this at wedge position. So do I need to represent chlorine as a seam? And let's suppose I'm adding hydrogen here. Okay.
Hmm.
Hmm. Now we start to give numbers. Hmm. Let's start with the bromine one.
Okay, and that's number one.
Yes, bromine is the one. Then second, this one, and it will be
Mhm.
third, and this is the fourth. Okay. So first, second, third. Okay. So is it clockwise or anti-clockwise?
Clockwise.
Clockwise. So it is R. Do I need to change this?
Yeah, yes.
See, the fourth group is on the dash side. So in that
Mhm.
case, we don't need to change. Okay. Say in this case, the fourth group is on the dash side. Okay.
Wait, I
I
thought
told
it was
you
the
this one.
opposite. Sorry.
Sorry. Opposite means? No, no, we don't need to change if fourth group is on the dash side. Okay.
But when we did because when we did the Fisher diagrams, you
Yes.
mentioned that if they're on the left or the right, and that's only where the wedge and dash is, then we would need to change it. Right? Or no?
Wedge or dash. So we need to. No, no, no. See, in Fisher case, there is some different thing because Fisher is a 2D molecule. And whenever we identify for direct 3D, then we are not changing if there is a, like, if fourth group is on the dash side. Okay. If fourth group is, where is the, okay. So if fourth group is on the wedge side, then we are going to change that.
If it's on the dash side, we will change it.
If on the dash side, yes, we are not changing if it is on the dash side. And if on the wedge side, so in that case, we are going to change that. But this is only in terms of 3D structure.
Oh, I don't think I knew about that. I remember learning about the Fisher method and how you
We
assign
discussed this one.
oh, maybe I don't remember or something. Oh,
Mhm.
maybe yesterday we did.
Not yesterday. When I'm describing some rules, then I write this also. So
Oh,
now we note down these things also.
oh, okay. That's really strange that I don't have that down. But I do have like the one for the Fisher where it's like if it's on left or right, you have to change
Mm-hmm.
the
No issue, you can note down now.
okay.
Then, okay. So now for
Okay,
this
sorry,
one.
sorry. No, no, no. I haven't written it down
Okay.
yet. I'm sorry.
Okay.
Just let me write it, please. Okay.
Okay. Okay. So now let's do with for this one. Here's the chlorine, and here is this hydrogen. Hmm. Are you solving this one?
Sorry, what am I supposed to do? I'm confused. What
You need to identify the configuration for this carbon.
okay.
Okay. Start give priority. This is the first. second, third, fourth. Is it clockwise or anti-clockwise?
It is anti-clockwise.
It is anti-clockwise. Okay. So anti-clockwise means S. Do we need to change?
Mm, no, no.
No. Very good. So now, is our structure is correct as I draw? No. The bromine on the wedge side is correct. Okay. But chlorine on wedge side is wrong. So what I'll do, I needs to attach chlorine as dash side and hydrogen as wedge side. Okay. And in this case, hydrogen is on the dash side. Done. Do you understand how? Hmm?
Yeah.
So now are you okay with this? Give me a sec.
Yes. Wait. Oh, the other one is all right. Sorry. Wait, sorry. Give me one second. Let me write that down.
See, for bromine, we solve that bromine, like for the chiral carbon, which is having bromine, is
Mm-hmm.
R only, okay? We solve that. But when we solve that chlorine on wedge side,
Mm-hmm.
okay, in that case, it is S. So what we are going to do, we needs to convert this into S. So I just change their positions. So if I change these position, the configuration will also change. Okay. If you are not understanding, let's start to prioritize this one, the first. Okay. And here is the second. Let's cross check for a time. Then it is for third and fourth. Okay. So for second, third, and fourth. Clockwise or anti-clockwise? Anti-clockwise. So it is
Mm-hmm.
S.
Mm-hmm.
Do I need to change? Yes. Okay, so now this is converting into R.
Wait. Oh, you need to change because it's on a wedge, right?
Yes, yes.
Wait. Give me one second. Wait, sorry. Let me just note this down fully.
Yes, yes, yes. You can
Because
take
there's
your
a
time and like
yeah.
assume that how I proceed each step.
Because there's like a few different parts of this
Mm-hmm.
problem, right?
Yeah.
Because it's wedge, so it changes to R, right? Okay.
Mm-hmm.
Okay. So the first one, okay, is R, and then this, okay. Oh, so that to match the configuration that they have noted, right?
Yes.
In the problem, okay.
Okay. Okay, now do the 12th question by yourself. 12th question. Here. Question number 12. Do you have?
Mm-hmm.
Okay.
Yeah.
Mhm. Question number 12. So in question number 12, there is S1 bromo, S1 bromo, 1 chloropropane.
Mm, question 12. Yeah, propane, not pentane. Sorry, I
Okay.
wrote down.
Okay. So now for this, you need to make a 3D structure.
Mm-hmm.
Try this one.
So only bromine needs to be S? Oh, chlorine is also on one. Never mind.
Firstly, draw a propane.
Oh, propane, methyl, ethyl, propyl. That's only three carbons, right?
Yeah.
Sorry, I don't know why I drew a pentane. I think I was looking at the one above it. One, two. Wait, only three? Oh, it's a triangle, right? Is it a triangle?
No, is there any cyclic return? Is there return as a cyclopropane? No, na. So
No,
it
no,
is
no.
a normal three carbons.
Okay.
Yeah.
Hmm.
Okay, propane done.
No, no,
Now,
sorry. I drew it in the cyclic structure. I have to change it.
okay,
Okay.
okay. So now, there is two groups. The first is bromo and one is chloro.
Mm-hmm.
Okay, bromo and chloro are present at which position?
The first.
Yes. So attach bromine and chlorine at the first carbon.
Uh-huh.
Okay. Now you need to identify S configuration.
Okay.
Okay. So in case of bromine and chlorine, you need to represent them as a wedge dash. Okay. Or you can represent in plain also. So let's see how you can do that. Okay. So three carbons. Let's suppose firstly I'll draw this one. Okay. One, two, and okay. Then at the first there is three atoms attached. The one and second, and let's suppose here is the fourth. Okay. Let's suppose I'm attached fourth group to the to the dash side, and then chlorine and bromine. Done.
Mm-hmm.
Any issue up to now? Like how I
Um,
represent this?
no.
No? Okay. So now I need to check this one that is this compound S or not. Okay. So let's start with giving numbering. So in chlorine and bromine, which comes first?
I think bromine.
Yes, bromine comes first. So bromine is having first priority, then chlorine, and
Mm-hmm.
then this one third, and here is the fourth. Okay. So is it clockwise or anti-clockwise?
It's gonna be anti-clockwise, yeah.
Hmm. Are you sure?
Oh, wait, sorry, clockwise.
Clockwise. Clockwise means R.
Mm-hmm.
Hmm. Do I need to change it?
Um, for because it's on dash. No, dash. You don't need to, right?
Okay, good.
Okay.
So is my representation of a molecule is correct?
Yeah. Wait, you did the bond line diagram. I think I was doing a branch or something. I don't know what I was doing.
You
I
can do
don't know what you.
anything. You can do anything.
Okay.
Okay, there is no issue. But in the end, you needs to represent them as the S configuration is showing. Okay,
Mm-hmm.
there must be S configuration. Okay, so can is this structure is right according to the like example? Hmm?
Mm, structure, right, according. If it's R, we would
No,
need to
because it
change it.
needs S. So how can I
Yeah,
change
yeah,
it?
yeah. The only way to change it is to change the wedge, right?
Hmm. Yeah. No, no, we can change anything like at any position, but in the end we needs to come S only. Okay, so what I'm going to do, I attach S all like bromine over here and chlorine over here.
Okay.
Okay, so let's suppose if I attached chlorine, then bromine, and then hydrogen. Okay, so let's start now. First, second, and third. So now is it clockwise or anti-clockwise?
Now it's anti-clockwise.
Anti-clockwise. So it is S. Do I need to change configuration?
No.
No. Good. Okay. So now this is correct structure. Do you understand that like how if there is a name is written, how we'll represent the structures?
Um, yeah, I just probably need more practice.
You can do for now also if you want.
Yeah, wait, um,
Mhm.
so you changed, like like instead, so the hydrogen was, as a in dash form, right? So I mean, if you like change hydrogen into wedge form, wouldn't that be the easiest way for it to change? Or it doesn't matter? Like you mentioned it doesn't
Yes,
matter, but like,
you can change anything. You can do anything at a wedge and any group at dash. Okay. In the end, you needs to come that the whole molecule needs to be S. Why I am not changing hydrogen? Because hydrogen, as I know that hydrogen is at fourth position, at fourth number always. Okay, hydrogen is having least priority, means it having fourth priority. So, as the fourth group is on the dash side, it doesn't needs to change. Okay, that's why
Mhm.
I'm putting hydrogen always at the like dash side. Okay, because I don't want to change in the end. I just want direct answer. That's why I'm putting hydrogen and I changes all other things. Now do you understand why I'm not changing the hydrogen? But you can change. There is no any issue with that.
It's just easier, right, to keep track of
Okay.
everything.
Mhm. Okay, tell me how you are thinking.
Hmm?
Like how you are imagining. Tell me,
We're thinking about what? I'm confused.
like about how we represent that. Do you want the hydrogen at a wedge position?
Well, that's what I thought, but then when I asked you, you said it doesn't matter, right? So if it's like
Yeah.
okay, like this, because like that's why I was asking if it's like easier
Mhm.
in a sense to do it this way because you're keeping like if you change the wedge, then you have to change everything else, right?
Yeah.
So this method is easier, I think.
Yes, because as we know that hydrogen is the fourth priority, and
Uh-huh.
at dash side, fourth priority doesn't needs to change. That's why I'm using this one.
Yeah, that I think this is a lot easier than what
Yes,
I was thinking.
yes, yes. Okay, okay. Now you can draw 11th question.
Um, okay. Is it okay if you could paste it onto here
Oh,
because
sure, sure.
yeah,
So in 11th question,
yeah.
you needs to draw the structure of 2R 3S 2,3 dichloropentane. Okay, now draw for this one. Do you understand?
Like to draw the
Hmm. To draw the structure.
structure.
So firstly, how many carbons are there?
How many carbons? Dichloropentane, right? Five, right?
Yes. You can draw on this one note only.
Oh, okay.
Okay.
Yeah, sure. Sorry. I can let me just get my stylus.
Why are you forming this as a cyclic? Is there any cycloreturn? You can draw in Fisher form or bond line form, whatever you feel is easy. You are on mute if you're trying to ask anything.
Oh, wait, I was on mute?
Yeah.
Oh, no, I was saying I don't know why I keep drawing the cyclic structures. I don't know like why I do that, but it's yeah, that's like wrong.
No issue.
Okay, and then so two, three. Okay, so two needs to be R, three needs to be S. Two, three dichloropentane. Okay. Um, dichloro means two. I'm just gonna say this is
Mm-hmm.
dash, and then this is wedge. Dichloropentane. Okay. And so the
Good.
second carbon needs to be R. Okay, so um So this is okay, wait.
So now start to give priority to cross-check this one.
Yeah, yeah, sorry. I was just erasing the numbers of the carbons because it'll confuse me. Um, one, and then I guess I don't know if this is even. I don't really know how to draw like the dash with the wedge together. I don't know if like what I'm doing is correct. If there's a specific way
Yes,
to draw that.
yes, it's right.
Okay. Um. Oh, and then two,
Mhm.
and then three, and then four. So like this. So that is R.
Absolutely.
Yeah.
Now let's do the second one.
Yeah. Uh. So one. Oh, sorry, I don't know what happened. Let me. So this would be one, and then I think this would be two, and then let's see, like hydrogen would be one, two, three, four. So like this, right? So that would also be that would be anti-clockwise. So S, I believe. Yeah. So then I think that's correct. Is two
Yes,
R, three S, right? Yeah.
good. Do you understand like how we are deal with these types of questions? Hmm?
Yeah. Wait, sorry, I'm just gonna take a picture of this. Okay. Okay.
Okay,
Mm-hmm.
okay. So now can we move to the Newman to Fisher conversion?
Mm,
Or do you want to ask something else? If let's,
sorry, I'm just checking my notes.
yeah.
Mm, let me see. Um, I think there was one question. Let me double check. Was it number? Did we just do number 26? Oh, no, no, sorry. That's something else.
Which one?
I just want to, number 26. I don't think we've done that. I think that's totally different from what we did. But can we do number 26? It also relates to like what you wanted to talk about. Newman to Fisher, or what is it? Newman to, did you say like
Newman to
Newman to
Fisher.
Fisher?
Okay, okay. Yeah.
Oh, so yeah, sorry, that's not
20.
what you said. Yeah, but it has to do with Newman. So, and I was just wanted to see if I was on the right track when I was solving this problem, if I had the right idea.
Okay.
Number 26.
Mhm.
Because
Mhm.
you have to identify like, what are the pair of compounds, and then you have to convert both into the same structure.
Yes, yes. Okay, okay.
Yeah,
Let's
so
start with Newman. Hmm. The 26th question we are going to solve.
mm-hmm,
This and here is chlorine, hydrogen, and CH3. And here is okay, so let's suppose CH3, hydrogen, Cl. Hmm. Okay, so this is the structure. Okay.
mm-hmm,
Now what I needs to do, we needs to convert a Newman into Fisher. Okay. So firstly, in Newman case, this is a type of anti form of Newman. Okay. Anti form of Newman. So what we needs to do, firstly, we convert this anti form into a normal one or into a what it's non. Give me a second. That this one is anti, another one. Okay, staggered and eclipsed. Okay. So anti form, or you can say that this is a staggered form of Newman. Okay. And now we need to convert this staggered form into a eclipsed one. Okay, so how I'll do that? See, firstly, I needs to add on this like okay, and let's suppose this is chlorine, hydrogen, and CS3. Okay, what I needs to do, just this carbon, I needs to represent this pink carbon as it is. Okay, and turn out these carbons into a different form. How? Let's suppose uh I am having, is I make a correct structure from this given example. It's 26th question now.
mm-hmm,
Okay. Yeah. So what I'm going to do, I needs to represent this CS3 nearby this CH3. Okay. And this hydrogen nearby this one, and the chlorine nearby this chlorine. So what I needs to do, I just needs a clockwise rotation. Okay, in the eclipsed form. So what I will do that let's suppose here, here, and here. I needs to generate a structure that is eclipsed, that is in eclipsed form. Okay,
mm-hmm.
do you understand that? Let's suppose there is two carbon atom attached with each other in a single bond. Do I like can I rotate them?
No.
If there is a carbon single bond,
Wait, sorry, can you repeat the question?
if there is let's suppose there is two carbon and carbon, okay, and there is three groups attached to these carbon, so is there any possibility that we can rotate this bond?
Yeah.
Yeah. If there is double or triple bond, then we can't. Okay,
Mm-hmm.
so that's why in this case both the carbon and carbon is attached with a single bond in the Newman form, anti form of Newman. So what we are going to do, we generate a eclipsed form which having a similar group to the similar side. Okay,
A similar group to what?
like see, similar group, similar side means this is the staggered form. Okay, now I need
Mm-hmm.
a rotation in these groups, the backside group. Okay, so this is carbon, here is hydrogen, and here is CH3 and chlorine. Okay, what I'm doing, I'm just switching these positions by just a circular motion and converting them into like this. Okay, I'm attaching CS3 over here, and after CS3 there is a hydrogen, and here is chlorine.
Mm-hmm.
Do you understanding? No?
Yeah.
Okay. Why I'm doing this?
To make it less, what is it called?
To
I don't
make
know the
it
word.
into fission, to convert this into fission.
Oh.
Okay. So after eclipsed form, now I'm converting this into the fissure directly. How I'll do that? The upper atoms, see, there is how many carbon, how many chiral center? Two. Okay, one and two. So I'm making two chiral center over here. Okay. Then there is two chlorine which is upside. So what I'm going to do, I attach one chlorine over here and another chlorine over here.
Mm-hmm.
Okay. And hydrogen and CS3 at the first carbon. Okay. So I am adding hydrogen and CH3 here. Okay. And same as hydrogen and CH3 or the next carbon, hydrogen and CH3. Okay. Let's see again that what we are going to do. When we draw a eclipsed form, so in eclipsed form, the atoms which is on the top side, okay, the atoms which is on top side, what we are going to do in fissure, we add one atom or one group on the top side and the remaining at the bottom side. Okay, majorly the carbon which is on the back side, this is carbon which is on the back side, is having
Mm-hmm.
this position, like the bottom position. Okay, and the front carbon taking this position, like the top position. Okay, so after ClCl, there is a hydrogen which is on left side. So I'll attach as it is, and CH3 on the right side on both groups. Hmm.
Mm. Okay.
Okay. Okay. So I'm giving you an example. Then you convert that example into the this form. Okay.
Yeah, yeah. I'm just gonna take a picture of this.
Yes. 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 You
Okay.
can. Okay.
Oh, there's a word. Oh my God. I've been actually sorry to describe the when there's a lot of groups in one direction. It's called steric interaction, right?
Yeah.
Okay, I haven't I've just remembered. I was trying to figure out that term for so long.
Mhm.
Like, because it
In case of
relates to Newman.
eclipsed form.
Yeah, that's what it relates. It relates to that, but I forgot the name. So
Mhm.
I didn't know what to yeah, how to describe it, but it's steric interaction. That's more eclipsed form is more stable? No, right?
Unstable.
It's unstable, yeah.
Eclipsed form is, yeah, due to steric hindrance, while anti or staggered is a little bit more stable.
Okay. These things
Mhm.
are more spaced out,
Okay.
yeah.
Yeah. Is it going to be tough? Hydrogen CS. Okay. Now you needs to make a. Okay. Let's start this. This is staggered form. Okay.
Mm-hmm. Sorry, are you asking
Let's
me to
try
make?
to.
I wasn't sure. Oh,
Yeah. Yes. Yes.
okay. Give me 1 second. Sorry, I had like my stylus somewhere. Where it went. Um, oh, I found it. Okay. Um, okay. No, what am I doing? Anti-staggered. Oh, and then oh, you have to rotate it. Okay. Mm.
Do I need to rotate this as much as I rotate the first one? Okay, let's. I'll make a structure so it will be more useful.
I think you would rotate the bottom parts more, right?
Yes,
This bottom,
but
the bottom part.
you can rotate the front part also, and it like at the end you only need this type of structure. Okay, so you can rotate front part also. So let's suppose
Sorry,
mhm.
I'm a little confused. Cause I'm looking at the example that you wrote at the top. I thought you were changing three different groups, right? So then
Yes, yes. You
that's
also
what I
need
was
to.
doing.
Yes, but see, in the first question, in the example, I'll rotate the back carbon. Back carbon means this one. Okay. But in this case, it is more easier if we rotate the front carbon on, like here is CS3. So I also need to, is there any CS3 over here? Yes. So I deep, shifts this to this side, to the CSC side, and let's suppose hydrogen nearby this chlorine, and then bromine to the nearby hydrogen.
Mm-hmm.
It
Okay.
will be more easier, I think so, if you okay. If we are going to do this one, that will more easier. What do you think? Like, do you having another option, anything else in your mind? Then from that we can also go. Okay. We can make anything, any structure, but in the end, what does matter? That is the only R and S configuration. Okay.
Mm-hmm.
We can rotate from front carbon, we can rotate from the back carbon also, but at the end we needs a eclipsed form. Okay, eclipsed form is the must, and in eclipsed form there is two atoms lie on the top side, as in like the structure I show in example. Okay, then after that we can represent anything in it. Can I make this structure? So this is the back carbon, CS3, hydrogen, Cl. We doesn't change any position of these atoms or these molecules. Okay, are you able to understand? Do you have any doubt, anything?
So, in order to make the Fisher diagram, you would need like when you're you would need the eclipsed, right? So when you're making the
Yeah.
eclipsed, you're not moving everything around, you're just moving whatever carbon you need, the
Yes, yes,
groups for whatever carbon that you need to like
yes.
change.
Yeah, according to our convenience we are like going to adjust these atoms or these molecules. Okay, because we only need a change from Newman to Fisher. And here is hydrogen and there is bromine. Okay, now up to now any doubt?
Mm, wait, sorry, sorry, it just takes me some time to process.
Or
Like, I'll let you know. Yeah.
Mhm.
I'm just trying to like make sure
Yeah, yeah.
I understand. The eclipse structure looks really funky, like really kind of like it doesn't look normal. Was that supposed to be like how it is?
There is a CH3 needed to be straight, but we can like we only need a conversion. So
Hmm?
do we understand this structure or not? That is the like important thing for us. We can represent like the upper eclipse form is okay or not.
The upper eclipsed one.
You
Um,
understand that?
did you just shift one carbon groups
In
or
which one?
one like for the first the example that you showed, did you only shift the groups on one carbon or on the back side? No, on the front side, right? No, no, back side. I think you
Back
said
side.
shifting on the back side.
I
Back
shift
side. Okay.
back side, yeah. And I shift all the atoms
Mm-hmm.
with like you can assume that there is a 180-degree shift in each atoms in that case.
Oh, okay.
Okay. While in the second one, we only shift to 60, 180, yeah, 60-degree shift. Is
60.
it 60 or 45?
Wait, how do we know like how much to shift?
No,
I'm
no,
a
I'm
little
just,
confused now.
no, no, no. I'm
Like,
just
what do you
telling
mean
you
to do?
that. Yeah.
Sorry?
You only needs to do that. First thing you needs to know that we need a eclipsed form to convert Newman into Fisher. Okay, only eclipsed form. So from any eclipsed form, you can draw Fisher. Okay, let's start with another examples and another molecules. Okay, wait a second. Mm. Do you want to take screenshot this for this one? Because this is
Yeah, sure.
yeah,
Okay.
okay. Mhm.
Okay. Are you gonna make the fisher?
Yes. Yes, let's suppose. So you can note down a thing that whenever we are converting Newman into Fisher form, okay, there is some things which is like needed. That is, mm, there is some conditions. So first to be that the Newman must be in eclipsed form, okay, and in eclipsed form, there must be two groups on two groups on top. What does that mean? Okay, let's start with a formula. Let's suppose I'm having this one. Okay, this. And what is this happening? Hmm?
What happened?
See,
Oh.
what is
I think that's just like a random, yeah.
okay? Okay, so let's draw a structure. Mm. Okay, so is this a eclipsed form or staggered form?
That one's staggered, right?
This is eclipsed form. In case of staggered, the groups are like a little bit far away from each other.
Oh, okay.
Okay, so this is eclipsed form. Now, is in eclipsed form, is there two groups on the top? Yes,
Here,
there is
yeah.
two groups on the top. Now, what we are going to do, we just let's suppose I'm giving numbers to these groups. Let's suppose I'm giving first and second, okay, then third
Mhm.
and fourth, then fifth and sixth. Okay, so now how I'll represent this as first I'll write here, then second, okay, then the third group comes to here, and then fourth group, then fifth group over here, and sixth group over here. Done.
Mm-hmm.
Let's suppose that now I'm giving you some example, and let's convert that example into Fisher form. Okay, chlorine, hydrogen, methyl group. and chlorine, hydrogen, and ethyl group. Okay. Now let's
Hmm.
convert this form into the fish.
Okay.
Yeah. After that, you understood like how we will convert a Newman into fish.
Okay.
Mhm.
I'm sorry, do you want me to do it?
Yeah.
Okay. Is that correct?
Yes, this is correct. Okay. So now do you understand like how we will convert Newman form into Fisher?
Yeah, but definitely need practice.
I'll share some questions. See,
Okay.
in this question, I'll form a eclipsed form by myself. Okay, but let's suppose if there is not any eclipsed form in there. So in that case, how we'll do? Let's suppose this is the compound. Okay, like this. And hydrogen, hydrogen, iodine, methyl, methyl, and iodine. So in that case, what you needs to do, you convert this form into the eclipsed form first, okay? And in eclipsed form, there is two groups must be on the top side, okay? After that, you can represent by this method,
Hmm.
okay? Any doubt, any issue? I'm sharing some pictures with you. Wait a second. If there is, okay, so like I don't have these problem now. I will share with Sir and they will share with you, okay, the pictures of examples. And that the examples are in majorly in the staggered form. So what you are going to do, you just convert the staggered form into the eclipsed and then convert eclipsed into the Newman. Okay?
Um, yeah, sorry, I'm just like
Mhm.
trying to look at the last example again.
Okay.
Um,
If you don't have any doubt up to like next class, So from next class we will start reaction mechanism. Or do you want to take a test? I will share a test paper with you, okay? Is that
Um,
okay? Like, are you available to solve the questions? Or
like when in class? Or
we can take in class also, but
there's
like
that like is that an efficient use of class time or should I just do it outside of class? Or what should I do?
you can do outside the class
Like
and
just time myself?
yeah.
Okay.
Okay, so
Honestly, I'm not ready yet. I really think I should do more practice and especially with
okay,
like
okay,
today's
okay.
lesson, it's like very new to me, so
That
yeah.
okay, okay, okay. No, not issue. So
Like
you
I'm
take your time first.
yeah.
You understood these concepts and cross check with me. Okay, and any doubt facing any sort of questions, problem,
Mm-hmm.
anything, then you can ask me. I am sharing some questions today also. Okay, so okay, we will take some
Wait,
note
sorry, I
on.
need to take pictures of like the note, like all of the notes for
Yeah,
like from
sure.
this
Of
lesson.
course, of
Yeah.
course. You can take screenshot for this one firstly.
Yeah, I've already taken one for that,
Okay,
this part.
okay. That I need to stop screen then. Shit.
Um,
Yeah.
like as far as I know, I think I'm more like I'm better at identifying like whether what like two pairs of like molecules are, right? And then a
Mm-hmm.
configuration I'm also good at define understand
Mm-hmm.
sorry, determining and then whether like a molecule is chiral versus achiral and then that sort of thing.
Mm-hmm.
That's like a lot easier now, at least for me, after like more practice, right? And more exposure. And like those concepts keep coming up again and again. I think just like the main thing is like when you have to like see how a structure looks in different forms, like and going back from one form to another, like converting from one form to another is like kind of where I get stuck. And then
Mm-hmm.
also I think these questions were relatively newer, right? Like where you have an
Yeah.
IUPAC name and then you're
Mm-hmm.
trying to identify like or you're trying to figure out like how can I get the chiral carbons to be like what they indicate like are as. So that's like really new for me. So I
Mm-hmm.
think that for that I would like need more time to prepare practice. And
Yeah.
then Newman projections are very new. Fisher
Mm-hmm.
projections are not as new, but in this context it's new for me,
Mm-hmm.
if that makes sense. So
Yeah.
I yeah.
Yes, yes, because these topics we only discussed today only, now. If we are going to practice from the first class, then maybe you are understood very easily, very quicker. But no issue, will take some time. You can understand by yourself, and if you want anything else, we will do in next class. I'll give you some questions. So through practicing
Hmm.
those questions, you are getting more into these questions.
Okay. Maybe in
Okay.
India you guys are really smart. Like you guys can
No,
master something in one lesson, but that's not me. I have to do a lot of practice.
no, you
I
are so
mess up a lot.
for sure. I know. You are taking these questions like you wants to understand these questions, these concepts also. Okay. So
Is that all we covered for today?
yes, we are covering these only topics today. Okay.
Oh, only
Yeah.
2 pages? I thought there was more. Okay.
No, no, there is some questions more. I told you that to take a screenshot for these questions because
Oh,
I'm
okay.
writing those from the Zoom pen. So
Okay.
they are erased once we're done. Okay, so like 4 to 5 pages, I think, from
Okay,
Zoom.
okay. Can I
Okay,
take the one in green, light green that you just showed me?
this,
Yeah.
these, yeah.
Yes, yes. And then the rest is like what we just covered like within the last 30 minutes, right? Or how new oh no, no, that
These
did
one,
we those were oh no, those were the first
yeah,
few, right?
but
Examples.
which we discussed already, like in before these, I told you that to take a screenshot because they are written from Zoom.
Which ones?
The ones
Oh,
where I show the numbers. You didn't take a screenshot from that?
Like sorry, which examples were those?
There is no example. There is some like the rules or stuff that like which position one, two, or three, and four will come. One, two, three, like these three. Let's suppose here and four and five. Do you take a
Yeah.
screenshot? Did you
I
take
think
a
I took a
screenshot?
screenshot, yeah.
Yeah, I told you because I think so. You take.
Identifying all the groups, yeah.
Okay.
Wait, oh no, was that in Zoom? That was you recently just did that, right? Problem? Because
Yeah.
I like where you were like, okay, if the fourth priority group is on dash, then you don't have to
No, no,
change,
no,
but on wedge you
no, no,
do.
no, no. The
Oh,
groups at in Fisher, like how if Newman is in eclipsed form, then how we'll convert them into the Fisher, that part.
Newman is an eclipsed. Yeah, I have that. That's in the green.
Yeah, yeah.
I think I have, yeah, I have all of that. Okay. Um, Also wanted to say, I think like Dhananjay sir was asking about the course syllabus.
Mm-hmm.
So I think I'm like my professor hasn't really like given me a lot of like access to anything yet. So all I can really go off of are like internet searches, and there is like a syllabus from past years. So I think I you already saw that in like when
Yeah,
you
I
first started
saw.
teaching me in the
Mm-hmm.
very beginning. I would just follow that like I'm just letting you know just in case you have any questions about the material or anything that we cover.
No, no, I get that syllabus.
Okay.
Yeah.
And
So
I
we'll
think we've been covering a lot of like stuff, right? So
yes, yes.
just reaction. I think there's mainly reaction
Reactions.
mechanisms, and then IUPAC. You said you mentioned like we would
Mhm.
do like
Yeah, when
yeah,
we proceed with each groups, each functional
yeah.
groups, in that case we will discuss.
Okay,
Yeah.
okay,
Okay.
okay. Thank you, ma'am.
Okay. Bye. Thank you.
Bye bye.